All right, today, extreme value theorem. This is one of our theorems. This is going to be a quick one. Remember these theorems that we've been talking about, intermediate value, mean value, Rolle's theorem, these kind of things. We're talking about continuous functions. So again, the extreme value theorem is an application of critical points where there are some certain conditions that are met, and one of those conditions would be that it's a continuous function. So the extreme value theorem guarantees, okay, and here's the important part if you're writing this down, extreme value theorem guarantees both a maximum and a minimum value for a function if the function is continuous on a closed interval, AB. So it doesn't have to be continuous on the entire domain, just on a section of the domain is fine between A and B. So if it's continuous on a closed interval, it has a, f of x has both the maximum and minimum value on AB. And that shouldn't really be another point. If function of x is continuous on a closed interval, then f of x has both the maximum and minimum value. And that's it. Extreme value. So there's always extreme value. And it might be helpful, you know, to show some graphs here. So I'm going to draw a few graphs. So from A to B, the function is continuous. And it's a function. I've got endpoints. So that means however I draw this, okay, so here's A, here's B, and here's A, here's B, it has to be a function. Okay, those are just 4 random ones, and you can draw ones that are similar if you want. But I'm going to just show you here. So if it's continuous, yep, question?
When you say A to B, do you mean like 1 point to another point?
Yeah. So this is interval notation. That's not one, it's not a point like, hey, the point AB, you know, like over A up B. No. It's this means interval. This is interval notation. So when it says on something like this, either with closed brackets or open brackets, and remember open brackets on an interval notation means that this is a hollow kind of point, right? It doesn't include A and B. But yeah, when it says on this, it means an interval of the domain, so a section of the domain from some x value A all the way to some x value B. And it's also understood that A is lesser in value than B, just like the alphabet. Like A comes first, then B. So it would look like this, okay? So as you can tell, if it's continuous, no matter how funky I draw this function, as long as it's a function, you know, then we have a minimum and a maximum. Now the maximum here is this value, right here. This is max. And the minimum is this value. They happen to be the endpoints, which is totally fine. That's totally fine. Here, this is the minimum. And because it's continuous, either the other endpoint or perhaps some point here, let's say that this goes just a little bit higher than that endpoint, then here's the max. So there's going to exist some point that's a minimum and maximum. Okay, and this maximum might occur at whatever this is, C or D or whatever. Now, an absolute maximum and minimum is really what they're talking about. There are locals as well, as we can see. Here's a local minimum, here's a maximum, here's a local minimum. But if we're talking about absolute, here this local minimum is also an absolute min. And this local max is also the absolute max. Okay? So there has to be a maximum and minimum value no matter what. Minimum here, maximum here. So it can be a collection of endpoints and points in the graph. Yes, it's called extreme value because there will be an extreme value on a closed function, on a closed interval for a continuous function. We obviously run into problems where it's not a continuous function, right? Like if I was to draw from A to to be like this, let's say. Well, what is this? It looks like maybe this is the maximum, but I don't know. Is it? Is this the minimum? It's discontinuous. So maybe you can't really tell if there's an asymptote here that you don't know about, right? Maybe it looks like that. So there's no max or min, right? What if there's a corner or something? This is actually a gap. If it's not continuous, there's a gap there. Well, this is not the min right here. And no, you cannot state what the nearest point to that is. Okay? And that's actually a very important point. It has to be continuous, because let's say that I zoomed in. Let's say I'm going to zoom. Watch this. I'm going to zoom in here. Okay, let's keep this in screen. Okay, I'm going to zoom in. I don't know how much I can zoom in. 477%. What can I zoom in? Oh, wow. Okay. So let's say that I'm at 477% zoomed in. And here's my big thick pen, okay? And I'm coming to this cusp. Right here, boom. Now there's actually a gap there. Okay, there's actually a gap. It's not continuous. So here's the rest of my graph. So you might think that, hey, the bottom of this is the minimum, and it might happen on both sides here. Well, no, it's discontinuous. So to actually identify what this value is impossible, because there's an actual space there. So if we were to zoom in even further, okay, if that were even possible, the dots would look like this. They would look like this. All these dots put together, that's what the line is made up of. Okay, it's a series of infinite dots. And if we blew this up, we wouldn't know what this last dot is, because it's infinitely small. So you would not be able to peg this value, because it's like, where does a dot end? If it's not given, we don't actually know where it ends. And even the graphing calculator, when it calculates a root, so here's the x-axis and here's a line that crosses it, when it tries to calculate this very value, because there's an infinite number of points that add up before this and after this, it has trouble guessing one single point, because there's an infinite number of points that cover the line. If you think about it that way, it's crazy. So we cannot note a minimum or maximum in these situations. All right, I'm sure that's really improved your life a lot. So it's going to help you. Okay, extreme value theorem. Any questions? Any more questions about extreme value theorem? I think I blabbed on enough, but yeah, you got a question? Can I scroll up? Yes, I can scroll up. What do you need? Is this part here? The blue area. There you go. All yours. All right, now lucky for you guys, I have some practice questions for you to do. I can come back to that in a second. I just want to throw this up here. So here's your questions from your text that I want you to do. This is covering the last few days of stuff. Okay, so you're going to get the rest of the class to work on this. And I do have a circuit assignment for you. And yeah, circuit assignment, it looks like this. So I might give this to you today. I might give it to you tomorrow. Might be something we'll do tomorrow, I'm not sure. But I want you to start working on your text questions here, just to get some practice in on these last few theorems. Okay, did you get everything you needed there from the notes?